Hello everyone, this is question 12 now on paper 2 from 2023 for Edexcel. And I think it's quite a tricky modulus exam question. So let's have a look. There's a couple of little traps in this question you have to be careful of. So it says the number of subscribers of two different music streaming companies is being monitored. The number of subscribers NA in thousands to company A is modelled by the equation given there, where T is the time in years since monitoring began. The number of subscribers NB in thousands to company B is modelled by that equation, where T is time in years since the monitoring began. Figure 2 shows a sketch of the graph of NA and the graph of NB over a 5-year period. Use the equations of the models to answers part A, B, C and D. Find the initial difference between the number of subscribers for company A and the number of subscribers for company B. Okay, so initial means we're talking about T is equal to 0. Okay, so in our equation for A, we've got t minus 3 add 4. So t is 0, so we've got the modulus of minus 3. The modulus of minus 3 is 3, so 3 add 4 is 7. At t equals 0 for B, we've got 8 minus 2 times t minus 6. So 2 times 0 minus 6, so the modulus of minus 6 is 6. So 8 take away 6 is 2. So the difference between the two is 7 take away 2 is 5. And notice that it says in thousands, okay? So the difference between the two companies is 5,000. So that's quite straightforward there for 2 marks for part A. When T is equal to capital T, company A reduces its subscription prices and the number of subscribers increased, okay? So presumably we're talking about at this point here, wherever we're trying to find where that is, okay? Suggest a value of t, giving a reason for your answer. Now, what I would say is when you've got a modulus graph and you're trying to find out where it is that like the vertex or the pointy bit of the curve is, compare it with what you would do if you were thinking about a quadratic, okay? So if we had t minus 3 all squared, we could see that the turning point of that quadratic would occur at when t is 3. And it's very, very similar in terms of how you think about these modulus graphs. So we've got modulus of t minus 3. So therefore, the vertex, the pointy bit, the turning point, this point here, is going to occur when t is 3. Okay, so t is 3. And what's our justification? Well, it's because that's where the minimum point of that graph occurs. Okay, that's part B. T is 3. Now here's the absolute challenging bit of this question. Find the range of values of t for which NA is greater than NB, giving your answer in set notation. In other words, we want to try and find out where NA is greater than NB. There and here. Okay, so we're going to be these two regions. So like going there and going there. So we need to find out where these 2 points are, okay? So in order to get that point and that point. So we need to set the two modulus equations equal to each other. Now here is the tricky thing, in my opinion. We need to set them equal to each other in order to find out where they intersect, okay? But I think we've got to be really careful about what we do because we don't ordinarily have to deal with two modulus equations equal to each other, okay? Normally what you've got is one modulus equation and then just a regular equation on the other side. And the way you would normally do it is you normally solve it once with this equation as positive and once with it as negative, okay? And then that works out, you get the solutions that you need. But what do you do when you've got the modulus on both sides of the equation? That's a little bit unusual because, you know, we've got, it kind of like increases the number of combinations because we could have them both as positive, okay, see what we get. And then to be perfectly honest with you, when I started solving this, I solved them both with one of them being positive, with them both positive. And then I initially said, you know what I'm going to do? I'm just going to make this one negative and leave that one positive, okay? And when I did it, I found I got an answer that didn't seem to make any sense. I got 7, which was like completely outside of the range of where the graphs were even going. So that got me thinking, what on earth's going wrong? Like, why have I got 7? And I think I've sussed it out that like what the thing is because we've got the modulus graph on both sides of the equation, to get the values that we need, we've got to think of them as both being positive or both being negative. And let me explain why. So in the region where they're both positive, we're thinking about the two portions of the graph here that have not been affected by the modulus part of the function. So in other words, it's kind of as though we just had, regular brackets t minus 3 out 4, and we had regular brackets 8 minus 2t minus 6. Okay, so if you think of them both as positive, we're dealing with these portions of the graph here, and we're going to get this solution. Okay, now when you think about them both as negative, so you'll notice I've got a minus there, and you'll notice that that minus has now changed to a plus. So I've put the minus on both sides of the equation. Then what happens is, whereas I was thinking about this portion for NA, I'm now thinking about this portion for NA, the bit that's been affected by the modulus, okay? And whereas for NB, I was thinking about that bit, now that I've got the modulus, I'm thinking about that bit. So when you've got the negative with both of them, then you're thinking about these two portions of the graph, and it's going to give you that solution. So really, I think a very, very tricky idea there. And the breakthrough idea is we need to think about both of them as positive or both of them as negative in order to get the two correct solutions. Okay, and that's what I've done. So for the first one, I've just thought of it as being both of them as positive. Regular algebra gives us 13/3. For the second one, I've thought of both of them as negative. Okay, so that minus, I've thought of a minus there, and that's become a plus now. Okay, so I've applied the negative modulus aspect to both sides, and that's given me 5/3. And those are the two correct values. Just for out of interest, just to show you why it goes wrong when you have one that's positive and one that's negative. If you've got one that's positive and one that's negative, you're thinking about the part of the graph that's not been affected by the modulus for one of them, and the part of the graph that has been affected by the modulus for the other. So if you've got one that's negative and one that's positive, you're thinking about this kind of combination, and it gives you a solution of where those two lines would meet over here. And if you did it the other way around, if you thought of that one as positive and that one negative, then you'd be thinking about this portion of that graph and this portion of the other graph, and you get another solution over here, which would make no sense. Okay, so just because of the nature of our particular graphs and the fact that we've got the modulus on both sides is why we've had to think of them as both being positive or both being negative. Okay, so I personally think that's super tricky and really, really easy to get confused about what's going on there. Okay, good. Right, so I'm glad we've established that. So that's given us the fact that we've got 13/3 and 5/3 as our two answers. Okay, now we're looking for where is the subscription for NA greater than NB. It's this region here and this region here. And it says give your answer in set notation. Of course it does, because they love to do that in this kind of question. So we've got t is a member of the set of real numbers where t is greater than 13/3 in the curly bracket. And because we've not got a connected region, we're going to think about the word or. It's either this region or this region. And when you're representing or in set notation, you use union, the U symbol. Okay, if it's a connected region, you think about the word and you would use the intersection symbol. But it's two separate regions, so we think of it as that region or that region, so it's union. And then the other region is t is less than 5/3. So t is a member of the set of real numbers such that t is less than 5/3. And you've got the curly brackets. So that's our answer in set notation there. Last little bit of this question, just for 1 mark. State a limitation of b. Well, the limitation of b is that if t was greater than 7, you'd get a negative number of subscribers. So NB is equal to 8 minus the modulus of 2t minus 6. So if you've got 7 in there, you end up with 8 minus 2 times 7 minus 6, okay, which turns out to be 8 minus 8. So it's actually 0 when t is 7. So if t was greater than 7, you're going to get negative subscribers, which doesn't make any sense. All right, I hope you found that helpful. I'll see you in the next video.